In type B, where the leading coefficient is different from 1, we have two methods to use here. One is by trial and error. This can be an efficient approach, but sometimes it is not. The other method is by decomposition. And you will study both. The method by decomposition is very basic and will always lead to an answer in a direct fashion. In question number, at least method number 1, let's take, for example, the questions I gave you earlier, the trinomials I gave you earlier in this lecture, which were 2x squared plus x minus 15. Now, as I explained earlier, the only way you can get a trinomial of this type is to multiply two binomial factors. It stands to reason, therefore, that the answer will have this form. Now, 2x squared can be obtained in several ways. You can have 2x here times x, and that is 2x squared, or you can have x to begin with and 2x over there. Now, there are several ways to get minus 15. Minus 15 can be obtained by taking plus 15 and multiplying it by minus 1. Now, that would not be the same as having plus 15 next to the x and minus 1 next to the 2x. So you can see that what we're engaged in here is sort of a trial and error process. The next step, really, if this is where we want to stop, although there are a lot of other selections, is to multiply these out to see if you can get back to the same problem, the answer equal to the given question. So you try a set of factors, multiply it out, find out if it's the same trinomial, and if it is, you have the solution. It's obviously a trial and error method. Here are some other possibilities. You see, 15 minus 15 is equal to minus 3 times plus 5. By the way, there are several other possibilities here that I haven't considered that are different than what I have just using 15 and negative 1. That is 2x times x. Instead of plus 15, how about negative 15 and plus 1? That's different than that again. So out of the first two choices of 15 and minus 1, I end up with 4 possibilities. To complete the explanation, you see minus 15 and plus 1. They still multiply to give minus 15 in every case, but every one of those factors are different from each other. And I haven't even considered the 3 and 5 yet. Let's have a look at those. 2x followed by x. Minus 5 plus 3. Now let's check this to see if I get plus x in the middle. We know we get 2x squared and the minus 15. That's looked after by the selection of these binomials. But to find out whether we get the middle term or not is we take these two and multiply them. That is minus 5x. We take the outside 2 and we multiply them. And the answer is plus 6. Well, plus 6x. The sum of those two amounts is what we're after. which is equal to plus x. Therefore, the answer to this question by the trial and error method is equal to 2x minus 5 times x plus 3. There are no other possible factors that'll give that trinomial. The same problem by decomposition. X squared 2x squared plus x minus 15. The decomposition occurs in the middle term. What decomposition simply means is to break it up into parts. And we decompose the middle term into two terms following this procedure. Multiply the coefficients or the numbers of the first and last two terms. First and last terms. That'll amount to minus 30. Now find two numbers whose sum is equal to the middle term number, and the product is equal to this product that we found in the first step. So now find two numbers which add up or add to equal the middle term number and multiply to equal the product found in the first step. This one here. Multiply the numbers in the first and last terms. Think about it. In the question, multiplying the first and the last number is equal to minus 30. Can you think of two numbers that will multiply to give the negative 30 and that will add and give the number in the middle, which is 1, plus 1? There's a limited number of numbers which multiply to give minus 30. 5 times 6, 30 times 1, 15 times 2. The combination of numbers that multiply to give minus 30 and add to give plus 1 are plus 6 and minus 5. Those multiply to give minus 30 and they add to give plus x. Now these two numbers, plus 6 and minus 5, are used to decompose the middle term into two terms as follows. This is equal to 2x squared plus 6x minus 15. We say that this is decomposed into these two parts. That's why the method is called by decomposition. This four-term expression is the same as this trinomial in amount. Recall the factoring type by grouping. The procedure now is simply factoring by grouping. In other words, we group 2x squared plus 6x together, and we group 5x minus 15 together. Careful of the sign here, because you have inserted, or I have inserted, the bracket in front of the negative sign, making that plus 15. Simply continue. This part factors into 2x, x plus 3. This part factors into x plus 3. And the common factor again of these two terms is x plus 3, leaving 2x minus 5 behind. I'm going to do this problem again over here, but I will switch 6x and 5x around, and you'll see that we will get the same result. Instead of using the decomposed numbers in that order, I will write 2x squared minus 5x plus 6x minus 15. Obviously, it's the same thing. That equals grouping 2x squared minus 5x, end of bracket, start a bracket, 6x minus 15. Take out x as the common factor. We're left with 2x minus 5, and here if we take out 3, we're left with 2x minus 5 again. 2x minus 5 is a common factor between those two parts, and x plus 3 is left behind. And there you have the same answer. The next factoring type is referred to as the perfect square trinomials. Or simply square trinomials. In ordinary numbers, the squares are such numbers as 1, 4, 9, 16, 25, and so on. We can have squares in dealing with fractions as well. For example, 1/2 squared is 1/4. 1/4 is a square. Similarly, 2/3 squared is 4/9. In algebra, squares of binomials will be our main focus. For example, we will deal with such things as a plus 3 quantity squared, which is equal to a squared plus 6a plus 9. Another example is 2x minus 3y quantity squared, and that equals 4x squared minus 12xy plus 9y squared. One more example, we have x minus 1/2 quantity squared, and that's equal to x squared minus x plus 1/4. Given a trinomial suspected of being a square because of the construction of the first and last term coefficients, we will then write down its factors. And the one is of trial and error. It's these kinds of trinomials that we are going to be given, which we will have to factor into powers, such as the left-hand side of the equal sign represents. For example, given that your trinomial is a squared minus 6a plus 9. The procedure is one of trial and error. And you might look at this trinomial and say, well, the first term is certainly a square. The last term, 9, is certainly a square. Possibly, this is equal to a sign, followed by a sign, followed by 3 quantity squared. Because the sign in the middle term is negative, you would automatically put the minus sign between the binomial. Why this is a trial and error solution is because now what you must do is test whether or not this power or these factors is the correct representative of a squared minus 6a plus 9. This, of course, when you expand, does equal to a squared minus 6a plus 9. I meant to put a question mark above this equal sign. There's always a question of whether or not the factors are indeed correct ones for the given trinomial that's suspected of being a perfect square. Here's another example. Is x squared plus 5x plus 9 a perfect square? Well, if it is, then the first term would be x, and the last term would be 3, and the sign in between would be positive. Now, we suspect that this is a perfect square because of those two terms in the trinomial, the first term and the last one. But when we expand this, we notice that this is equal to x squared plus 6x plus 9, not the 5x in the middle term as we have in the original problem. Consequently, this is not the correct factor, or they are not the correct factors of the given problem. Here's another example. X squared plus 10x plus 9. We have the same situation once again. Is it possible that this factors into the perfect square x plus 3 quantity squared? And the answer is no, because once again the expansion is x squared plus 6x plus 9. But you have to be careful with this particular problem, mainly because there are factors for it. Don't completely abandon the question just because it's failed to be a perfect square, which we suspected it might have been. What this factors into, recall your rules for factoring trinomials where the leading coefficient is 1, that the factors are x, find two numbers which multiply to give 9 and add up to give 10, and the answer is plus 9 and plus 1. So this particular trinomial is factorable. Here is another example. I have 16x squared, which is certainly a square on its own, minus 8x plus 1/4, and 1/4 is a square on its own. So the possible answer here is that this equals 4x, there's a minus sign there, and 1/2 quantity squared. That's the question, and that seems to be a possible answer. If we expand this to test our solution, we get our 16x squared. If we multiply the rest of it out and obtain the middle term, it happens to be double 1/2 of 4, and it amounts to minus 4x plus 1/4. And now you can check the middle term and notice that the answer, that 4x minus a half quantity squared is the possible answer, is incorrect. So once again, our analysis did not lead to a perfect square. Here is another similar example that may lead into a trap, and you have to be careful with it. If I gave you a question such as, let's pick this one here as a question similar to this one here. In other words, is a squared plus 6a minus 9 a perfect squared? It certainly looks the same as the question posed earlier, except that this sign here, instead of being positive, is negative. Well, if this term on the right is negative, it is impossible for this to be a perfect square, because when you multiply this part of the problem in the binomial factors 3 by 3, whether it's positive or negative, a positive times a positive will lead to a positive sign, and a negative times a negative will lead to the positive sign. So it's impossible to obtain perfect squares out of trinomials where that sign is negative. There will be some questions like that in your exercise, so be careful. The next type is called the factor theorem.